Welcome back to the deep dive. Today we're going to try and sort of cut through the noise around deploying generative AI.
Yeah, there's a lot of noise.
There really is. Because, everyone seems to have a Gen AI pilot project going, don't they? But the real challenge, the big question is, how do you actually get those proofs of concept out of the sandbox and into, well, reliable production quality applications?
Yeah, that's really the multi-million-dollar question, isn't it? When we talk about production quality Gen AI, we mean stuff that's accurate, consistently accurate,
Consistent.
and has proper governance built in. It's safe to use. And our sources today, they actually lay out this really structured path. 5 stages, basically, to get you there.
5 stages. Okay, a clear roadmap.
Exactly. And it's crucial because, look, the data shows something like 71% of CIOs, they're actually planning to build their own custom models. So they really need a clear deployment strategy, not just, vague ideas.
Wow, 71%.
Yeah.
That's huge. And it points directly to something our sources really stress.
Yeah.
Even before stage 1, right?
Yeah.
Just foundational bit.
Absolutely. The non-negotiable prerequisite. Before you do anything else, you have to get your data infrastructure right. Specifically, adopting data lakehouses.
Data lakehouses, okay.
That's the bedrock. If your data foundation isn't robust, isn't scalable, isn't secure, well, the whole Gen AI thing just kind of falls apart.
It makes sense.
And lakehouses are key here because Gen AI, it just eats up massive amounts of proprietary data, both structured, like, your sales records, and unstructured documents, internal wikis, emails, all that stuff.
So why a lake house specifically? Not just a big data lake or a traditional warehouse. What's the edge?
It really comes down to unified governance and schema flexibility. When you're training these models, you need seamless access to high-quality data of all different types. A lakehouse brings all that together under one roof, essentially. It means when you feed your private data into an LLM, you've got solid access controls, audit trails, clear data lineage. Doesn't matter if it's a neat table or some messy scanned PDF.
Okay, so the data plumbing has to be rock solid first. Got it. All right, let's get into the path itself then. Stage 0. Foundation models. This is the starting line, using those big pre-trained models.
Right. Everyone starts here. And these models, broadly speaking, they fall into 2 buckets. Proprietary ones, think GPT 3.5, Gemini, and then the open source models, which are getting incredibly powerful, like Llama 2.
And there's a big strategic choice there, isn't there? A trade-off.
Definitely. What's the key difference you need to weigh up?
Performance versus control, I'm guessing.
Exactly that. Proprietary models might have had a bit of an edge historically on some benchmarks, maybe, but the open source options give you something really vital.
Which is?
Full control, total governance oversight. And crucially, guaranteed data privacy because you run them on your infrastructure, not sending your data out to a third party.
Right, no external dependencies there. And to really illustrate that point, our sources dive deep into one particular model. DBRX.
Ah, yes, DBRX. It's a great example of a state-of-the-art open-source LLM. Really shows where things are headed, especially on efficiency.
What's special about it? The architecture.
Yeah, the architecture is fascinating. It uses something called a fine-grained mixture of experts. MOE, for short.
Mixture of expert.
Okay, think of it like this. Instead of one giant brain trying to do everything, you have a team of specialized experts.
Okay. So if I ask it a coding question, maybe just the coding expert part lights up, saving energy.
That's the idea, precisely. DBRX has, I think, 132 billion parameters in total, which sounds huge. But because of MOE, only about 36 billion are active for any given input.
Wow, okay. Much more efficient.
Hugely efficient. And that's why it performs so well. It actually surpasses GPT 3.5 on many benchmarks, and it's very competitive with Gemini 1.0 Pro.
And it's not just theory. The numbers on code generation are pretty stunning. DBRX hits, 70.1% on human eval? That's a standard programming test.
Right. And that score actually beats out some models specifically designed for coding, like Codal 70B.
So a generalist beating the specialist. That's impressive.
It is. But the really big takeaway here is the efficiency. Inference, actually using the model is up to twice as fast as something like LMA270B.
Twice as S?
And training these MOE models, it's about twice as FO efficient as training a traditional dense model.
Yeah.
Overall, the whole DBRX training recipe was nearly 4 times more compute efficient than their previous models.
Okay, so the message is loud and clear.
Yeah.
Efficiency is king now with foundation models.
It really is the new performance frontier.
Right. So assuming we've picked our foundation model, maybe an efficient open source one like DBRX, we move to stage 1, prompt engineering.
Yep.
This feels like the entry point, the quick wins. especially maybe you don't have a big data science team yet.
Hmm.
Just experimenting with off-the-shelf models.
Exactly. This stage is all about augmenting workflows, not necessarily full automation. How can these tools take some of the load off? And the sources give a great example: automated analysis of product reviews.
Ah, yeah, I saw that. And the potential impact is pretty significant. The sources suggest LLMs doing things like summarizing, classifying, searching that could help with tasks taking up, what, 60–70% of some employees' time?
Imagine freeing that up. And it doesn't have to be super complicated. You could set up a pretty simple pipeline, right? Feed in customer reviews, maybe separate them by star rating,
Mhm.
and then let a manager just ask natural language questions like, okay, looking at the one-star reviews from last month, what are the top 3 complaints?
Instant, actionable insights
Mm,
instead of wading through pages of feedback.
exactly. And there's a cost angle too. In one test they mentioned processing 51 million reviews. Doing it in-house versus using a third-party API saved about a third of the
The
cost.
third. That's significant.
And they scaled it up massively, handling like 760,000 reviews an hour. So even simple prompt engineering, when done right and industrialized, can deliver real value.
Okay, but eventually you hit the limits of just prompting. Right, you run into issues with accuracy or the model making things up,
Yeah.
hallucinations,
Absolutely. And that's the trigger for stage 2, retrieval augmented generation, RAG.
RGA. So this is about giving the off-the-shelf model some extra brains,
Yeah.
feeding it specific context, like company handbooks or internal wikis.
Precisely. You're not changing the underlying model itself. You're just making it smarter for your specific query by retrieving relevant, proprietary, hopefully non-sensitive information and adding it to the prompt dynamically. It boosts quality and accuracy quite dramatically.
Okay, so the basic steps are gather your documents, clean them up, chop them into smaller searchable pieces,
Mm-hmm.
index those chunks in a vector database, vector search as mentioned,
Right.
and then connect that whole system up to your LLM endpoint.
That's the classic R pipeline, yeah. But like everything in this space, it's evolving fast. One really critical finding in the sources is how much you can improve our RAG quality by feeding it not just text, but also real-time structured data.
Okay, hang on. Real-time structured data. That sounds more complicated than just pointing it at documents. Can you give an example?
Sure. Think about a typical customer service chatbot for, say, an online retailer.
Okay.
A customer asks, "Where's my recent order?" Now, to answer that accurately, the bot needs the latest shipping status, maybe the price paid, the delivery estimate. That's all structured data changing all the time.
Right, from databases or APIs.
Exactly. And the bot needs to seamlessly blend that real-time structured info with maybe the company's general return policy, which might be in an unstructured document.
Ah, I see. So it's combining both types of info.
Yeah, and that requires some pretty sophisticated coordination behind the scenes. You need new kinds of services. The sources talk about things like feature serving and function serving, working together with your vector search. It's definitely not just about pointing the LLM at a pile of PDFs anymore.
That sounds like a real step up towards a robust production system.
It absolutely is. Now, let's say our RAG, even this advanced RAG with structured data, still isn't quite hitting the mark for personalization or domain depth. And, importantly, leadership is now convinced Gen AI is valuable. Then you might be ready for stage 3, fine-tuning a foundation model.
Okay, fine-tuning. This is where we really start tailoring the model itself, using our own specific proprietary data.
Mm-hmm.
And this loops back to that crucial need for secure data architecture, data lineage. Everything we said about the Lakehouse Foundation.
Absolutely critical here, because now you're actually training the model, modifying its weights based on your sensitive data. But the potential payoff, the ROI, can be huge.
Yeah, the sources had a really compelling case study, building a custom, smaller LLM just for generating AI documentation.
Right. And what was really striking was the cost and effort involved.
It seemed incredibly low. Like 2 engineers, about a month's work, and less than $1,000 in compute costs for development and experiment.
Less than $1,000. It's kind of mind-blowing, isn't it? And the result, they got a model that was better, faster, and resulted in a 10-fold cut in inference costs compared to using big commercial sauce LLMs.
10 times cheaper to run. So how is that even possible?
Yeah,
That sub-$1,000 cost must rely on some clever techniques.
definitely. It hinges on these parameter-efficient fine-tuning methods, often called PEFT.
Yeah.
The most well-known are LoRa, that's low-rank adaptation, and then there's QLoRa, which adds 4-bit quantization on top for even more memory saving.
LoRa and QLoRa's. Okay, but wait, if fine-tuning can be done for under $K, Why are those 71% of CIOs still finding it challenging? Is the real cost not the compute, but maybe getting that proprietary data clean and ready,
Mm,
or the specialized skills?
I think that's a really insightful question. The sources seem to imply exactly that. The bottleneck is shifting away from raw compute cost towards, well, organizational readiness. Do you have that clean, governed data in a lakehouse? Do you have the engineers who understand how to apply these advanced techniques like LoRa effectively?
Right, it's not just plug and play. And speaking of applying LoRa correctly, there was a specific technical insight from the experiments, wasn't there? About where to apply the adaptation.
Yes, that was really interesting and kind of counterintuitive. They found the best performance didn't come from fiddling endlessly with the rank value, the dollars.
Okay, so not just how much adaptation, but where.
Exactly. The key was targeting all the linear layers within the transformer model for adaptation, not just focusing on the attention blocks, which was common practice.
All linear layers, got it.
In simple terms, it matters where you inject that specialized knowledge across the model's structure. Getting that right could save a ton of experimentation time and cost.
Fascinating detail. Okay, that takes us up the ladder to stage 4. Pre-training. Building a model entirely from scratch. This sounds like the major leaguers. Who actually needs to do this?
Yeah, this is the biggest commitment for sure. It's generally reserved for situations where your data is incredibly unique or domain-specific, think medical imaging, complex legal precedents, maybe proprietary scientific data, or scenarios where you absolutely need full control over the model's foundational knowledge, perhaps to completely avoid any biases baked into models trained on general web data.
Total control, unique data. But
Mhm.
historically, this cost
No.
a fortune, right? Millions.
Astronomical sums. But again, the sources show this barrier is also crashing down. The example they use is training the Stable Diffusion image generation model.
Ah, Stable Diffusion. How much did they get the cost down to?
Researchers managed to replicate Stable Diffusion 2 for under $50,000.
Under 50K. That's an
Right.
eightfold reduction from the original cost, wasn't it?
8 times cheaper. And it only took about a week, 7.45 days, using 128 high-end GPUs. Still significant compute, but moving rapidly towards being accessible.
Okay, how? What were the efficiency tricks there? They must have done more than just use better GPUs.
Oh, yes, several clever things. One was pre-computing image latents, basically doing some prep work up front. Another was using low-precision formats for certain internal calculations, layer norm and group norm. That saved a lot of memory,
Memory saving.
which allowed them to use a microbatch size 4 times larger, so cramming more data through the training process simultaneously. They also used techniques like fully sharded data parallelism, FSDP, to distribute the work efficiently.
Makes sense. Smart memory and workload management. What about this scheduled exponential moving average thing, EM?
Right, scheduled EM. That's a neat trick for saving time. EMA is a technique that helps stabilize the model's learning towards the end of training, but you don't necessarily need it running the whole time.
So you schedule it.
Exactly. They figured out they only really needed to apply EMA during the final, 3.5% of the training run.
It's at the very end.
Yeah. Do the heavy lifting, then just apply the finishing polish. Saves a good chunk of compute time without hurting the final quality. It's all about these smart optimizations now.
Really clever stuff.
Oh.
Okay, phenomenal. So we've climbed the ladder, built our amazing, efficient custom model. We're done, right? Ship it.
Ah, if only. That brings us to the crucial ongoing stage 5, LLM evaluation. The job is never really done.
Continuous evaluation.
Yeah.
Why is this so vital, especially for Gen AI compared to maybe older ML models?
Well, a few reasons. LLM performance can be really variable. It can be super sensitive to tiny changes in the prompt, and maybe most importantly, defining ground truth is hard.
Right.
For creative tasks or summarizing complex ideas, there isn't just one single correct answer. So those traditional metrics we use in ML, like BLEU score, Rouge for text, they often just don't capture quality well. They can be pretty useless, actually.
So you can't just automatically score it against a perfect answer key. We need a different approach.
We do. And the emerging best practice is this concept of using an LLM as a judge.
Using one AI to grade another AI.
Essentially, yes. Research highlighted in the sources shows that if you use a very capable LLM, like GPT-4, to evaluate the output of your model, its judgments on things like correctness and readability align with human graders surprisingly well, like over 80% agreement.
Over 80%, that's
Yeah.
really high. That could automate a huge part of the quality control loop.
It's a massive lever for scaling evaluation, but there's a cost consideration, naturally.
GPT-4 isn't cheap to run constantly for grading.
Exactly. So the cost-saving tip here is interesting. The research found you can actually use a slightly less powerful model, like GPT 3.5, as the judge, and still get good results if you do two things.
Okay, what are they?
First, use a simple, low-precision grading scale. Think integers like 0 to 3 or maybe 1 to 5. Don't get overly granular.
Keep the rubric simple.
Right. And second, provide what are called few-shot examples. That just means giving the judge model one clear example for each possible score on your simple scale.
Show it what a 3 looks like, what a 2 looks like, etc.
Precisely. That combination, simple scale few-shot examples, makes GPT 3.5 much more consistent as a judge, and it can cut your evaluation costs by something like 10x compared to just using GPT-4 raw.
10 times cheaper. That makes automated evaluation much more feasible.
And wasn't there also something about offline evaluation, evaluating the retrieval part of RG separately?
Yes, that's super important for RG systems. Before you even worry about the quality of the final generated text, you need to make sure the right information is being retrieved in the first place.
Checking the inputs before the output.
Exactly. So you use offline tools and metrics like precision at K, recall at K, NDCG at K. These measure how good your retrieval system, the embedding model, the chunking strategy, etc., is at finding the relevant documents before they even get sent to the LLM. You tune that part first. Okay, so it's a multi-layered evaluation. Check the retrieval quality, then check the final generation quality, maybe using LLM as a judge.
That creates a really robust, measurable quality control loop. It ensures your production model stays accurate and reliable over time.
Wow, what a journey. We've gone from, just playing around with prompts, stage 1, quick wins, all the way up this ladder, to potentially building highly customized models from scratch.
Mhm.
And the economics have shifted dramatically. Fine-tuning potentially under $1,000, pre-training under $50,000. It's becoming accessible.
It really is. Thanks to those efficiency games, MOE, LoRa, QLoRa, smart scheduling like IME.
So the big takeaway for you, listening, seems to be that getting to production quality Gen AI isn't about finding one magic application. It's about understanding this maturity path.
Yeah, knowing which stage fits your needs, and crucially, leveraging these efficiency techniques. Plus, you absolutely need rigorous continuous evaluation. That LLM as a judge approach looks really promising there.
Okay, so here's a final thought to leave you with, something to chew on. We've seen these drastic cost reductions in fine-tuning and even pre-training driven by efficiency. Does this mean the real competitive advantage in Gen AI is shifting? Maybe away from just having the biggest foundation model, towards having the best, most unique proprietary data to train smaller, highly specialized, efficient models.
Data as the ultimate differentiator.
Something to think about as you plan your own Gen AI journey.